Okay, in this video, we're going to start talking about cognitive theory, particularly the information processing aspect of it. So before you got here, you should have probably already watched the crash course video, just those 2 minutes. You're welcome to watch more than that. It's still interesting, but just those 2 minutes are related to what we're going to talk about today, and our unit on cognitive approaches to learning. And you should have annotated the Willingham article as well. So I'm hoping you feel a little bit comfortable with some of these key terms like working memory, long-term memory, cognitive load, and the way that these things are related to each other. But I'll go a little bit into that more in this video. But here I'm going to give you a little bit of context of cognitive theory. I'm going to talk a little bit about cognitive architecture, and then add a little bit of texture and a little bit of understanding to how we're thinking about learning, knowledge, and teaching in cognitive theory. Okay, so cognitive theory draws on a variety of fields, but most specifically cognitive science and of course cognitive psychology. But it has some of its origins in computer programming, thinking like how might you program a computer to think like a human to play chess, right? So something like that. This happens in the 1950s-ish, and for our purposes, there's not really a single person you need to associate with cognitive theory. Although if you really want one, Piaget sort of fits in here. And for those in P254, which is Educational Psychology for Teachers, we've been talking about behaviorism. And just as a quick recap, behaviorism, and Skinner is associated with behaviorism, it's another kind of learning theory that for the most part has kind of been, I'm not sure if debunked is the right word, but it's kind of been torn down quite a bit. And because Skinner kind of looked at humans as a little bit more like animals, and saw the mind as a black box that since we can't see inside the mind, we're going to focus on behaviors. Well, cognitive theory and cognitive architecture sort of thinks about this a little bit differently. It kind of positions humans as the thinking animal. It rejects this black box idea. So we still have an input and output, but instead of the input and output and us not being able to see inside the mind, we're saying, okay, we may not be able to see inside the mind, but we can actually build models for what we think is going on. So cognitive theorists said, what happens if we at least try to come up with a model for how thinking happens? So we have these inputs, then something sophisticated, habits of the mind, happen, and we can do some work to model that. So what we're going to talk about today is kind of the model or a model for thinking about it from a cognitive perspective. So here's the model that I'm going to offer you. I want to put a little asterisk next to it because it's much more complicated than what I'm going to share. But this model should help us in terms of how we're thinking about teaching and learning, and it should be enough for the purposes of our class. So, okay, let's imagine something happens. There's an input of some kind. Something happened in the world, and you automatically take it in through your sensory memory, right? So sensory memory, part of this is we're talking about visual or touch or hearing, taste, are basically our senses. So we have kind of this sensory memory. So something happens, sensory memory. So if there's a song playing in the background, even if you're not really listening to it, you are sort of noticing it, right? Let's say you want to transfer something from that sensory memory to actually thinking about it. Well, what could happen is you could not do that, and then memory just wouldn't register with you. That memory wouldn't even come in. That input would never do anything. We could just say, I'm not going to pay attention, or I'm not going to even allow that to happen. Or you could try and get it into your very limited working memory. You should think about working memory as conscious attention. Working memory is what you're consciously thinking about. Like, of course, you've got some stuff stored in the background, and there's some stuff that might be happening around you that you're not paying attention to. Think about working memory as like your workbench. It's conscious. It's what are you consciously or actively thinking about at any given time. Working memory is very, very limited. You can't think about that many things all at once, right? So how are you going to get something from sensory memory into working memory? Well, you have to pay attention to it, right? So, for example, right now, if you're tuning out, you might be hearing my voice, but not actually processing anything. It might be in your sensory memory, but you have to pay attention to it for it to actually enter your working memory where you can start to process it. You're also going to get some pattern recognition happening at that point. So you might be hearing somebody talking in the background, but then as you start to pay attention, you'll start to hear what they're saying as words rather than just as like the teacher on Peanuts, you know, wah, 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 the Charlie Brown teacher, wah, wah, wah in the background. Okay, so now we've got this limited working memory. And it's very possible, once something's in your working memory, consciously thinking about it, to immediately forget it, to not actually do anything with it, right? So we can just let it go. So even though that input came in, we let it come to our working memory, we can just let it go. So what are you going to do? Because if it's something that we don't want to forget, what can we do? Well, we can rehearse. You can engage in rehearsal. This is kind of like repeating something again and again and again in your maintenance memory, in your working memory. So some phone number that you're trying to think about, or you can try and store it in long-term memory so that you can access it later. Long-term memory, unlike working memory, is really not so limited. For our purposes, we're going to think about long-term memory as essentially limitless. Essentially, you can encode an unlimited amount of information, okay? So here we have working memory. It's quite limited. If you don't want to have to repeat something forever and ever and ever so that you can keep thinking about it, you're going to need to encode it. And you're going to need to be able to bring it back from long-term memory into your working memory so that you can work with it later. And that's called retrieval. So we have this encoding and retrieval. So if you want to engage in doing something with the information, so problem solving with it, combining information, actually engaging in a complex task that involves multiple things, thinking about multiple things at once, like, for example, trying to write an essay on the cause of the First World War, you need more than just returning some simple facts to your mind, right? You need to actually be able to use those facts too. So now your working memory needs to be able to retrieve prior information from your long-term memory and use that information. Now, again, I've said this multiple times, working memory is really, really limited. So, some studies have kind of said that we're only able to hold between like 5 and 9 bits of information, or the Crash Course video said between 4 and 7, but basically a small amount of information that we can hold at once in our working memory. So how do you relieve that load on the working memory? Well, if you can remember things really easily, like you've memorized them super well, you've encoded them really, really well in your long-term memory, then you can retrieve that really easily, right? So if you've memorized it super well, your phone number, for example, or an email address or something, like it, you don't even have to think about it, it can come to you. So that's going to relieve things on your working memory. So that's why if you're trying to speak a foreign language and you know the vocabulary really well, you're going to be much more conversational than if you're simultaneously trying to put together a sentence and really work hard to remember the particular vocabulary words that you want to use, right? So that's one way you can limit the load on working memory. You can really have memorized stuff really well, and that way it automatically retrieves. It doesn't take a lot of working memory for you to retrieve that information. And the other thing is you can just not do very complicated things. So if you're just trying to memorize something, then you can just send it back and forth between working memory and long-term memory. But if you're trying to do something really sophisticated, you really need to have that information well stored. So, sorry, that's a little bit more convoluted than I wanted it to be. The last little asterisk I wanted to make is that we don't necessarily, for our purposes, want to think about things evaporating from long-term memory. It's not like things fall out of long-term memory, even though memories do decay. But for our purposes, they don't just disappear. If somebody can't retrieve something, it's because there's a problem with retrieval. That's when it drops out. Not that the memory has disappeared. Do you feel that difference? So it's not that it disappeared, it's that you can't retrieve it. So together we're going to call all of this the cognitive architecture. That's kind of this model is cognitive architecture, which is opposite from, again, this behaviorism black box idea that we talked about earlier. This cognitive architecture idea, this is the model for what's happening cognitively in the mind. So if you're having trouble solving a complex problem or doing something complicated, it's possible that you never encoded the relevant information in the first place. So your breakdown could be there in the encoding. It's possible that you did encode it, but then you can't retrieve it. So your breakdown can't be in the encoding, it's going to be in the retrieval. It's also possible that your information isn't connected usefully. So you're trying to remember 7 or 8 different facts because you're trying to remember them separately instead of somehow coding them together. We'll talk about that in the next part of this unit in next week. And so all of those things can provide too much of a burden on working memory. So if working memory is trying to do too many things at once, it might sort of overheat, in air quotes. Well, we'll think about that as cognitive overload. So we want to be really thoughtful about how difficult the tasks are as learners and as teachers. Okay, so I apologize if that was cognitively overloading. That was a lot to kind of go through. We did a lot of theory in a really small amount of time. So remember, we're thinking about what knowledge is as our starting point, and then learning and teaching follow. So from our perspective now in cognitive theory, now that we have access to cognitive architecture, we want to think about knowledge as A, discrete pieces of information. So you can know a fact, but also the ability, B, the ability to do something with that information. So knowledge is not just memorizing all the 50 states, it's also being able to, make some claims about the generic culture of some regions or something like that. So do something with that information. So then learning is acquiring information. It is encoding information. But you also want to encode that information in a way that's retrievable, in a complex way that allows you to retrieve it together, and reducing working memory demands. Because the lower your working memory demand is on retrieval, the more you can actually do to manipulate the information. And so for teaching or for learning, like what we're trying to do, teachers are really trying to organize knowledge in a way that best allows people to practice encoding and retrieval. Again, we're thinking from a cognitive perspective. So trying to organize knowledge to best utilize or practice encoding and retrieval. Okay, so I know that was a lot. This video is already a little bit too long, but so please use the annotation feature to add your questions and comments if you have any. But hopefully that's just kind of a recap of a lot of the things that you've already read, and maybe that model will just help. And so hopefully it's just a little bit redundant, but hopefully maybe clarifies a little bit of why it's important for us. All right, so now I'm going to ask you to go do a content check and a reflection to make sure that it's all clicking, have an opportunity to see if that's processing, make some connections to your own lives, and kind of things that you want to be doing with this information. And then next week, the readings are going to be on how to support our learning and or teaching through elaboration, which helps us to code better, and generation, which helps us to retrieve better. So we'll talk about that more in the readings next week. Those 2 readings should help you with your own studying as well. So then the next time I have a PowerPoint for you from me, it'll be on social cognitive theory. You don't have to worry about that for now. We'll get there when we get there, but that's kind of the next PowerPoint where we'll take cognitive theory next, which is a slight deviation from cognitive theory, but applies a lot of the same principles. All right, see ya.